Hello all, my name is Amit Sharma. Welcome to BISP Self-Learning series. In today's session, I'm going to walk you through with how to build a BI solution. In the previous sessions, we discussed about fundamental of data warehousing, business intelligence concept, dimension modeling, facts and keys. In today's session, we are going to be very focused about understanding logical data model and various aspects associated with this. So many of time you get a data model from the business and you have a set of questions which are required to be answered. You need to understand the set of questions available to you and the data model available to you both should map to each other. It means your data model should be capable enough to answer business questions. So in today's session we'll take a couple of examples and understand what is the need of remodeling your model, data model, to meet your business BI reporting requirement. It is important to understand the way business user thinks in a different way and technology thinks in a different way. Business user always like to ask questions in their own vocabulary. It's a business oriented language or it's a human oriented language. So if you give them data model which is more technical, maybe it is difficult for them to answer. Let's take a more complicated model. This is the data model. It's a graphical presentation of dimension and fact. If you give this model to the user or even to a report developer and ask them to and they have a set of questions, business user may not be capable enough or may not be able to understand this model and ask any questions. So we need to hide the complexity. This is called layer of abstraction. I show you another face of the same model. This is called technical metadata. And I show you the second phase of the same model. The same information we reorganize over here. You see it's a logical grouping of data. Like it is subject oriented, like time, product, office, customer. And the vocabulary, the name, keywords, definitions are used, which is simple English like language, which is easy for the people to understand. So when I like to query any data, for me as a business user, pretty easy. I can drag and drop required column and process. I mean, I don't have to worry about the underlying technology, how things are worked. The metadata organized in a way which map to my own language is a business vocabulary, and reorganize in a way that which is my job. So I should focus my job as a business user to bring the required information rather than on technical complexity. So this slides talk about the business user asks a question in a reality, some set of questions which is required to be answered by your technology solution. Your business question to be answered by your underlying data source. But the language business users speak, they are typical English like language, a human understandable language. Your physical source cannot understand it directly. Or my underlying source is not model considering the user requirement. Therefore, we need to convert this model into conceptual model and logical model. Today, we'll focus on designing logical model and various aspects related to this. Now, this is another important point to be discussed. You see there are two kinds of metadata, business metadata and technical metadata. Metadata is all about data. In large enterprise solution, you have so many dimensions, you have hundreds of dimensions, hundreds of facts, so many keys joined. It is difficult for people to memorize them. So prepare a data dictionary. And technical metadata talk about all the technical content like table name, column name, keys, join, constraints, all is a technical metadata. If I take in this example, my technical metadata would be these dimensions, their column type, column name, column keys, joins, join type, and various other information is a technical metadata. Now business user cannot ask any business question directly on top of technical metadata. It has to be simplified in a way that they can submit their business questions. So it is required to be, there's a layer of abstraction, hide the complexity and simplify in a way that people can ask any question. So we'll take a couple of scenarios and see how it is to be addressed. Now let's take one data source as our requirement. Okay. I'll take this as my data source. I have taken a slice of the enterprise data warehousing model. but the whole model was pretty big. To make it easy to understand, I just focus on one part of it. So what does my first requirement says? As per my first business requirement, we need to filter business data to map our BI reporting needs. The couple of scenarios I mentioned over here, we'll take up one by one. The data come from the source system may not be designed considering your BI reporting needs. And therefore, before your user receive any information from your technical metadata, it has to be converted or reorganized in a way that it makes sense to the user. So I can prepare a logical data model or semantic model where I would address all these complexities so that the user can submit the query in a reporting system. So bringing only meaningful data to the BI reporting. Let's take a couple of examples. In our case, there is a dimension called product. I have given a source table name as TBL product history, right? And TBL product history, there's a column called product status. This is a pretty old table. This is, let's say, this is 20-year-old. We are managing data for last 20 years, pretty old, right? And we have not deleted any records from this table. This is the records are getting accumulated over the period of time. So over the period of time, the volume of data in this table becomes so huge. It is shown over here. There are 100,000 records, but out of 100,000 records, only 20,000 records are meaningful for BI reporting. Business user like to see only those products which are active. We have got two kind of products, active product and retired product. Look at this sample data. From table product, I can query this product, dim product. I look at the sample data and you see I have a column over here called product status. Now some products are active, some products are retired. In my system, I need only those products which are active, which makes sense to my business intelligence reporting, because querying on retired product doesn't make any sense to me. It doesn't yield any meaningful information. So all this complexity you handle before you start building a report in a logical model, right? You apply a conditional statement on your logical data modeling. There's another scenario, very common. I have a table called customer. Now customer again is a huge table, huge dimension, which has got a lot of customer data. Now for business intelligence reporting is all about business users or analysts would like to query this table and would like to bring certain meaningful pattern on analysis. So one of the requirements I receive from my client, the client says, though customer dimension is pretty huge, they like to see only those customer data who has visited to my store in last 90 days. So they are more like, they like to evaluate the customer, how frequently customers are visiting to my shop, or they like to filter out the information so that they can make some real-time analytics on recent data set. So I would further apply a where clause on my data model before I prepare any report on top of that. I'll use my data model. In this data model, I apply a where clause on my customer dimension. I have got a customer dimension over here. Right. So this source, this data model can be used for reporting system provided that you do required changes. Two examples we see, you apply filter on customer, you apply filter on product. Let's see another scenario. You may also like to decide your promotional strategies. We have a column dimension table over here, dimension promotions, which talk about different kind of promotion related to my product, different kind of promotions. So we have a different kind of promotion strategies. We would like to tune our promotion strategies depends upon some criteria. A business says we would like to focus only for those products where consumer types is kids, right? The business say in this quarter we would like to leverage the sales for only those products where consumer type is kids. Therefore, they would like to know what is my promotional strategies where consumer type is kids. Maybe I type a filter over here, where clause with consumer type is kids. So overall, in filtering business data, you see in logical data model, you can filter information so that when business user navigate your data and report, it bring only meaningful information rather than bring a huge amount of data into the system and slower your system performance, you can bring filter data from source itself and pull only required amount of data. You can filter over here, right? Now, so you do filtering in a business model, in a logical data model. What else you do? You can write a complex, simple to complex business logic. Business logic could be simple. When you apply for a credit card, the bank you submit your request, they also apply business logic. They see your salary statement, they see your buying capacity, accordingly the credit card assigned to you. The same example, similar example I've given over here. My business team would like to identify customer visit pattern. How often customer visit to my shop, and accordingly they like to categorize customers, and maybe subsequently they like to reward some points to the customer, promotional strategies, something they like to do. But important point over here, there's a business logic apply. If the average difference between two customer visit date, when customer visit to the store, in last two time, what is the difference between two customer visit date? Maybe first time I visit in the May, and then I visit in June. So between the dates between two customer visit date, which tells me customer frequency. If customer visit date is in between 10 to 30, we'll tag the customer type as frequent customer. So I have a business logic over here which is specify what is the customer type, and based on the condition we tag a customer profile. If customer visit in between 10 to 30 days, we call them as a frequently visit customer. Otherwise a moderate if customer visit between 30 to 60 days. If customer visit between 60 to 360 days, we call them low visit. If it is more than 360 days, we call assume customer is inactive. So such business logic, you see conditional statement I have written, an expression, type of customer, customer type, depends upon one business logic. Another example, we would like to identify product discounting policies. What is my discounting policy? Product discounting policy determined based on certain parameter or certain calculation or certain expression. The expression written over here, product, if the product current stock availability minus stock in hand is greater than 100, then we need to provide 10% discount to all product. In simple English word, if my product is lying in stock for more than 100 days, right, and product is not being sold, it is time to give a discount and get rid of the product. Sell the product with discounting and get the money returned. So these kind of business logic people, the business team required to apply, and all these business logic we can apply on our logical data model, primarily designed for this purpose. We take two cases. Let's get into more detail. In a business model, you also take care of other aspect like aggregation. What is aggregate? Generally, when I give you an example of aggregate. Let's talk about one transactional system, a typical system, which Walmart use or any retail organization use. You see the pattern of the data in my system, which record day-to-day transaction. So one row is one transaction. In simple word, when I go to Walmart, buy something, this is called one transaction. The data stored over here in a more granular level, it means every minute transaction happen and records it. But for analytical purpose, we need a more summary information, summary data. Therefore, there is a need of aggregation. So aggregate is like pre-calculate of your information so that query performance could be faster. Now in this example, we see aggregation with respect to time dimension, right? Now imagine my data available to me is on daily transaction. This is my sample data. The transaction is capturing on daily basis, right? But business user wanted this data to be consolidated or roll up to make it more meaningful to the user on month level. So have you been using SQL query? You would have been writing like this. In a typical SQL query, use sum and group by. For example, let's say I have data at month level. We call aggregate at month, right? Here I'm capturing month level. I can have more summary data from month level to quarter, even more summary to year. In a typical RDBMS, we create a SQL expression to aggregate this value. So for example, I want aggregate at month. My query would be select sum of sales, and I want at month level, so I put year, quarter, and month from blah blah, some table, and apply group by year and quarter. So in this example, the aggregation happening on runtime calculation taking place. I could create a pre-aggregated table or view. Well, view will not add any benefits to my performance, so I can create a pre-aggregate table. It could be a pretty simple statement like create table AGG at aggregated month. And this way, you can, rather than you calculate on the fly, the table would be pre-calculated, calculate beforehand. The only flaw or limitation with this process, every time you data modify, the aggregate table has to recreate or repopulate. So this is first level aggregation where data is pre-calculate at month level. The second level aggregation, data is pre-calculated at quarter level. Third level aggregation where data is pre-calculated year level. So we have seen with respect to the time dimension. You may require to create a couple of aggregate tables with respect to time dimension, product, customer, consumer, or different dimension type to speed up your query performance, especially when your user query often on high data, data at higher level. This lower level at month and higher level is quarter and year. Right. So this is another important parameter you pay attention while designing a logical model. You add aggregate tables. There's another scenario. Okay, I'll first talk about. There's another scenario called many-to-many relationship. You may also have to deal with some complicated scenario where data model required to be tuned. Let's understand this requirement and how logic data model can resolve this issue. So I have a sample data to understand this requirement. In this case, see, I have got two tables. One's in sales manager, another one is business deal. In salesperson or sales manager, I've got three columns: salesperson ID, salesperson name, and deal, which business deal he has done. So salesperson John, his primary key is SP101, has done 2 business deal. John has done 2 deal, Carrie also has done 2 deal, and Mac has done 1 deal. Similarly, there's another table called business deal D101 done by 2 salesperson. In one simple word, from salesperson to business deal, my cardinality is one to many. One salesperson can have multiple business deal. We can write over here, one salesperson involved in multiple deal, and one deal done by multiple salesperson. This is an example of one to many and many to one forms a many-to-many relationship. Multi-key value. So sometimes your source system may have many-to-many relationship which is required to be addressed in your logical data model. That could have done simply by adding up a intermediate table called bridge table. If this table has facts, then it is called factless, then it is called bridge table. If it doesn't have a fact, it's called factless fact table. To address this problem, what I did, I spin off this, cut the column which is causing multi-value and put into my bridge table. So here in my salesperson table now have salesperson name and salesperson ID and their name, and business deal table have business deal ID and the name, and all the multi-values kept over here. So you see salesperson SP101, who is John, has done 2 deals. Similarly, deal 101 done by 2 salesperson. Right? So by adding up a bridge table, we can address many-to-many cardinality. And now you see it is one to many. One salesperson can have multiple business deal and one deal done by multiple salesperson. It forming a many-to-many relationship. Adding up factless fact table or bridge table may also be required while you're designing your logical data model. You need to understand the requirement very carefully and need understand the need of it. Okay. Then you may also, we try to convert our model to a star schema primarily for a reporting purpose, and whenever your performance is one of the important criteria. You always like to, when you design a BI solution, your query performance should be speed of thought, very fast, right? So we would like to convert snowflake model with a star schema. This is also required to be done. You see my current model is snowflake model, where my store dimension is further normalized to region dimension. I would logically sum them up, logically join them, where my cardinality is one to many. In one country there are many cities, one to many. So my parent or driving table would be region. I would join region to store and finally convert it into a star schema. Graphically you can do it pretty straightforward. I'll show you this model. Graphically what you do, you simple join it, two table join with single table. It becomes single dimension, right? This turns out to be star schema. Well, if you are very new to star schema dimension concept, I would recommend you to go through our video tutorial about dimension modeling and multidimensional database. So this is also required to be handled in your logical data model. Sometimes your requirements are even more complicated. You have more than one fact table. When there are more than one fact table, the complexity also increases up. Let's see this scenario. In one of my scenario, there are three fact tables: sales fact, fact sales, fact cost, and fact advertisement cost, right? And when there are multiple fact tables, there are set of dimensions which share this fact table. These dimensions are called confirmed dimension. You see in my example, dim product is in between your cost and sales, therefore it's a confirmed dimension. We also need to identify confirmed dimension when it comes to multiple fact table. When there is more than one confirmed dimension, the complexity also increases up, and business do not get the desired data. Because if you look at your query, pretty straightforward. My query could be very simple. In this confirmed dimension, I'll take a snapshot and explicitly highlight the confirmed dimension we have. So there are three confirmed dimensions in my current example: product, dim time, and dim promotion. So if I ask basic query, dimension only query, where I need a list of products, their promotion, and list of product, let's say make this query, I need list of products for which promotion is active, for last 3 months. Or we may ask simple query, I need a list of product and their promotional strategy, list of products and their promotional strategies. Now this kind of question require me to pull data from dim product and dim promotion. Now you see in this example, I cannot join product and promotion directly. There are more than one path exist. Promotions, dim product and dim promotion. This is required to be joined. Now these can be joined using two paths. Either I can join using fact cost. This is one path, or I could join using my dim product and promotion could be joined using fact sales. So there is more than one way for the query to process, or sometimes your reporting solution do the Alice, they stitch the query, they create a query which consider both the paths together, which may not yield the right output. So if I simple visualize this, what I mean to say over here, the source reporting system may query data from more than one path. This is path 1, this is path 1, this is path 2, and this encourages me to use, this is path 2, path 1, and let's say this is path 2. So when you have a multiple confirmed dimension, the complexity is also there. We need to address this issue as well. How do you address? There could be multiple ways to address it. one simple way you can create alias. Sorry, let me open it. I can create an alternate name to the same table and join with this. So you can join, you can remove this multi-path join, or if possible and business meaningful, you can join these two fact table to a single fact table, considering one of the dimensions a confirmed dimension. So there are multiple ways to handle this. In a subsequent session of a data modeling, we'll talk about how to handle exactly this kind of situation. This is also to be addressed during your logic data modeling design. So you need to identify your confirmed dimension, convert your galaxy model, this is called galaxy model, to the subject specific model. Alternatively, what I could have done, I could convert this model into subject specific. What I mean, I'll make a multiple piece of this. You see, one part could be this. I can remove this two facts, and this become my perfect star schema. Let's say we denormalize this, become perfect star schema. Otherwise, it will continue to be snowflake model. So what kind of analysis I do in this? This is all pertaining to sales. I could call this sales analytics. This model is subject specific, which talk about sales analytics. What else I could have done? I could have split this piece, and I would have another model. Let's focus on this part only. One fact called cost fact, and I found I've got fact table called cost fact joined with product, time and promotion. This could be my another star schema, which may talk about all the analytics or queries pertaining to your sales analytics or expenses related. All business query can be answered. The fact cost talk about different kind of facts associated with cost, like unit cost and unit price. So you see, you've got two model. One talk about sales analytics, one talk about cost analytics. I could further delete this piece and only focus on another fact table called, advertisement fact. I could further focus only on this model. So how do you split your model? There are multiple ways. The question over here, technology is not a challenge. You need to ensure the data which is being processed after designing your model should be appropriate and make sense to my end users. So you also convert Galaxy model to subject specific data model. Now another important thing, many of time your source doesn't have a time dimension, and I hope you understand the value of time dimension. All analysis is time bound. There are two simple examples I shown over here. What kind of analysis your business user like to do? One very common analysis, people may use a different term called month over month sales growth. Month over month sales growth. I would like to see my sales growth pattern for last 3 months. What is my sales growth pattern with respect to different countries? Now in SQL query, there is no way. In traditional SQL query is not designed to answer these questions, or maybe you need to write multiple SQL query to answer this question. So conventional RDBMS is not designed to store or to present data in this format, which is required to manipulate in your logical data modeling. Another example is YTD sales or cumulative sales, aggregative sales for a given year or given quarter. Y or QTD says quarter to date, total sales for a given quarter or total sales for a given year. In case I make it, this is my total sales for whole quarter. I should have used this way. If I make it YTD, this makes sense. YTD of 2013 would be total sales for all quarter. Let's make it this way to more easy to understand. I have this data with me. I've got different years of data. I have different quarters and sales, right? And I just make it gray colored for the people to easy to understand. And I've got data for 2013, right? For all 4 quarter, 2013, all 4 quarters. So this is my quarter 1 data, Q1, Q2, this is a Q1 data, quarter 1 data. So my quarter 1 data, let's say, easy to understand, I make a simple value. What is my QTD? QTD would be total, this is my QTD, which will be total sales for all the months for a given quarter. Or I could add another column over here and I say for given quarter there are 3 months, right? January, February and March. And what you see over here is monthly sales, and I can have a QTD view over here, quarter to date. A quarter to date would be a sum of all the values. It would essentially be 600. So similarly, people like to see YTD, QTD, this kind of manipulative. In order to do this kind of analysis, one important thing is that you're supposed to have a time dimension in your logical data model. A sample time dimension given over here. Generally, time dimension is populated with many of time it is populated with stored procedures or custom queries, but you essentially have a time dimension. In my time dimension, you see there are 2 important things. I've got 2 kind of time: calendar, like calendar year, calendar month, calendar year, calendar week, and I've got fiscal year, fiscal month or financial year, financial date. In my time dimension, we have got all time dimension elements like year, quarter, month, week, days, first day of the month, last day of the month, first day of the week, all important things. So you ought to have one time dimension for all kind of analysis in your system. This is another important parameter you need to pay attention. Finally, I think we discussed all the important points. So these are a couple of cases I discussed about you need to pay attention when you design logical model. We would like to simplify our reporting system, so my business user should pay attention to their queries, business queries, rather than technology. Similarly, my report developer should pay attention to the report design, formatting of the report, rather than falling into the complex technical activities. So with this, I'm going to stop over here. Your queries are welcome. You can mail to me or you can browse to our site in order to watch more videos. In our subsequent video, we'll talk about the more example of logical data modeling. Please watch our video series, subscribe to our YouTube channel, and watch our video series to understand complete BI solution implementation strategy. Thanks for joining today's session and have a great day ahead.